Hello, ladies and gentlemen, and welcome back to another screencast by your Earth Science teacher, Mr. Stano. When we last left off, we were looking at different characteristics that can be used to help us identify minerals. Minerals, though, we can delve a little bit deeper into. We want to know what they're made of or the predominant structures that we see within minerals. This structure that is found within minerals will directly relate to a number of different characteristics that we are going to look at or have looked at in these past few screencasts. Minerals are composed of elements. Some of the elements that they're mostly composed of are oxygen and silicon. We could take these oxygen and silicones, combine them to create what is called a silicon-oxygen tetrahedron or a silicate. Silicates is just SiO2, where it's containing both oxygen and silicon. Here's our silicon, and here's our two oxygens. And silicates make up a lot of different minerals, or this structure is within a lot of different minerals. And we can look on the composition of our Earth Science reference table. And you can see here as we scroll down, there's a number of different elements. But if you don't know the actual symbols, we can look down even further, and this will give us some of the common symbols. If we look at the composition of Earth's crust, because remember, these minerals come from the Earth's crust, rocks come from the Earth's crust, we can actually see the elements that make it up. And notice we have oxygen and silicon right here. These, which make up our silicates, and you can see that it's predominant. These are the predominant two elements that are within our crust. We go to page 1 on our Earth Science reference table. We can see that if we go to the crust, we have percent by mass. That oxygen and silicon are the top two. We can also look at the percent by volume and notice that those two make up the most. The silicon-oxygen tetrahedron that I just mentioned a little bit earlier is something a little bit different. It's the basic structural unit of silicate minerals, but this is where we have 4 oxygens surrounding 1 silicon ion. And it looks like this. Here's our silicon way buried deep within these 1, 2, 3, 4 oxygens. If we take a closer look, what we get is an actual pyramid that forms. It's a little bit clearer to see right here. So this oxygen, another oxygen, there's the 4, and our silicon right here. These make up the silicon-oxygen tetrahedron that is found within a lot of different minerals. Speaking of the internal arrangement of atoms, or the atoms inside a number of different minerals, talc versus diamond have somewhat, their arrangements of atoms look somewhat similar, but they're a little bit different. Here's galena. Notice that we have this nice structure. Okay. The physical properties of a mineral are determined by this internal arrangement of atoms. So these repeating patterns that we see, such as diamond, talc, or galena, are going to help make those minerals what they are. Magnetite, same thing. Halite, it's got the cleavage because of these internal arrangement of atoms. Graphite, it's nice and soft, used to make the pencils, or that alleged lead inside pencils, has an internal arrangement of atoms which is loosely packed, which makes it soft, which is great for pencils. At this point, you should be able to use your reference table to identify a number of different minerals based on characteristics or the properties that we've covered. Okay. Remember, determines the mineral or basic properties such as its hardness and cleavage is the internal arrangement of atoms. I cannot stress this enough, that how these atoms are set up in either repeating patterns or whatever patterns it may be is going to determine how it breaks, how hard it is, and a number of different other properties. That's it. That's the end of minerals. Like I said, we'll be practicing this a lot more in class. There's nothing like that hands-on experience that we'll get with them, so hope you enjoyed it. Take care.